Hello.
Okay, good afternoon and good morning. If let's say you are watching us in other part of the world, yeah. My name is CC Lee from Axiomtek. I've got here Ken Leong.
I'm Ken Leong.
Yeah, okay. Good to see you again here today. So, yeah, this is the third less Zoom's less Sembang AIoT. This is the third live that we have. In fact, we want to have this live, what we call, actually last week and next week is supposed to be our live session actually. So because we want to patch up something, especially the first session that we have is not very clear at that time actually. So we have a comment. The second time also we make some mistake. Sorry for that. Technically some of the word is reversed somehow. Yeah. So that is why we make it a point to do another live just to patch up some of the missing part in the first live that we had. And then the second part also we want to extend a little bit. Yeah. So that is the whole intention. I hope you are enjoying. And then, yes, you are watching the Jom Less Sembang AIoT. And then for Jom, Ken Leong, in Malay word, actually, we are doing this broadcast from Malaysia. Of course, Jom, for some of the foreigner or you are away from Malaysia, you are not from Malaysia. Jom normally, how to describe Jom?
Something like let's do it together.
Let's go, something like that. Let's go, and then let's Sembang. What again on the Sembang? What is Sembang actually?
Sembang means we try to discuss together.
Yeah, Sembang we discuss together. So or in Indonesia they will say bicara. We chit chat or bicara, something like that. So let's Sembang AIoT came from there actually. Yeah. So today we are, as you know, we are doing some patching. I hope the video today is clear, and then our voice is okay. Can I check with our crew? Is our voice okay? Okay, our voice is okay, because we don't want to do the third mistake. In fact, I've being bombarded by one of the professors say your video is lousy, not clear. So that's why this is the time that we make a point to do another one for you. I hope everything is clear. So yes, you are watching the Jom Less Sembang AIoT today. Today we are going to bring to you if you are watching our last live, you can see there is a Kiwi that we are highlighting. We are trying to do talk about this Kiwi. So, and not very different from the last, but we have this Kiwi, but it's doing the other part of the thing that later I'm going to show you. Kenneth is going to show you. As usual, our live is going to be, we want to bring more information. We want to bring more knowledge. You treat it as a knowledge. We want to bring you some technology, how you actually can do things differently. Yeah. So yesterday, I think I attended, me and Geno attended the Microsoft, one of the session on the AI, Azo Studio AI. Yeah, in one of the tech line, it stated there, with AI, you have to do something, every industry have to do it differently with AI, something like that. Yeah, that is a tagline, published in Microsoft. So of course, today we have this same gadget here. We are having the same gadget here. But before that, I would just want to touch something related to M2M. What is this M2M, and what is this IoT? How is these two different? What are the things that make them different? In fact, if you trace back, M2M is actually, that is our era, my era, maybe not Ken Leong era. That come kicks in, I think, in 1998, 1999, year 2000. At that time, Yeah, at that time. That time we I think in early 20s, this M2M is brought popular and very famous. We talk about M2M or machine to machine. Yeah, machine to machine. That machine to machine is actually talking about the device talking to another device, or one machine talking to another machines, or another what they call another one of the what they call maybe another system talking to another system. That is the whole thing about machine to machine. And then machine to machine, that is the time where because you see, when you talk about machine to machine, we are talking about connectivity. Yeah, we are only talking about connectivity, but it's not maybe not internet yet at the time. Yeah, of course, internet come way before that. So there is some what they call the direction towards at the end of the day, the machine to machine is got to be on the internet. Yeah. So let's trace back. During that time, I think all the device communicating to another device is purely or largely by TCP/IP protocol. Yeah, TCP/IP. That's why during that time, I can share with you. During that time, we are doing. We are working on some microcontroller. For example, in those time, 1998, 7. We are talking about big microcontroller. Yeah, from microchip. Wow, that is very junky already at the time. How you have a big microcontroller can do this one, do that, and then during that time, if you want to find a LAN interface, for example, Ethernet interface, that is very difficult to find in most of the low-level microcontroller. Yeah, that's why during that time there are companies like, for example, Rabbit. I don't know whether the company still exists or not, but Rabbit microcontroller, Zero, from Zilog, that kind of a controller. These people actually built some of the LAN interface. I think most of the companies from America. Yeah. So during that time also, we were exposed to people like 286 kind of processors, especially Intel, and then 386. Some other company already took over. They produce Intel-based or x86 kind of processors that come with a single Ethernet. Well, that single Ethernet is to us is very powerful at the time. Yeah, because it's allow the TCP/IP talking between machine to machine. That's how the M2M actually come about, I think, during that time. And also, the 2G communication, GSM, has becoming popular, at that time. You are able to do text messaging, on an edge, and coming to 3G, at that time, at the time. So this thing can become very, what I call, very useful in terms of you want to do M2M, there's no problem. But of course, along the way, internet had also come up very, very fast during that time. That's why in about earlier 2010, earlier 2010, IoT come out. We talk about IoT. We talk about Internet of Things. We are no longer M2M. That's why you see because in terms of IoT is also talking about connectivity. Yeah, it's also the base fundamental is its connectivity. But IoT do it in a different way. Of course, internet is one of the contributors that make up the thing, differently. And also some standard protocol in the IoT has made this one even easier to access, hardware. And there are three major things. One of them is communication. Communication, you go to 4G. Right now, 5G, of course, 4G. And then you, at that time, in terms of software development, software development, programming language become more easier to do. Not like last time, you need to talk TCP/IP on the DOS platform. That's related to software, yeah. So one part is communication, the other one is a software, and then the third one is a hardware. Yeah, I think these three main contributors that boost up the whole IoT. That's make the M2M become subset of the whole IoT, become one of the things. Does these people still practice the end-to-end? Of course, yeah, because it's related to connectivity, especially on the industrial engineering or software engineering or computer engineering side, or especially on the engineering application. In the engineering application, we tend not to touch things that is working fine. Yeah, will you agree with me?
Yeah.
Sure. So engineering people don't dare to. Hey, things running okay. You don't touch. Hey, you got IoT. Hey, wait. IoT. Later. Let us get this thing up. If you want to move one step away, we want to do some testing. We want to do evaluation. So that's why there are many of the device or many applications still rely on M2M. For example, one of them is like you have a pump controller, a pump controller from pump house to a pump house, from a pump in the pump house, in the pump control room. You're actually sending SMS to trigger another pump, something like that. That is also one part of M2M. Not much of IoT, but IoT in a big picture in IoT, you can see, in terms of accessibility, yeah. So you can access the device connectivity very easy, and then in terms of transparency, you want to access all this data is also very easy, yeah. In terms of standardization, because of all these three things also make the IoT different right now nowadays. So that, if you are hearing what I'm saying, M2M, IoT, this make the difference, in the history point of view, yeah. So that is conclude my the difference between the M2M and IoT. So of course, in this live also, we want to share with you on something related to, in the very first session, in our this title, we talk about AIoT, AI and IoT. Of course, there are many people who are still confused. AI, ChatGPT, is it? So their AI mentality is ChatGPT. Yeah. Oh, I know. Yeah. ChatGPT is very relevant right now. In fact, if we are talking about ChatGPT, last week I have a very good experience, with ChatGPT. It is actually giving me a very technical solutions that I didn't actually thought of. Yeah, that can be that powerful. ChatGPT is powerful. ChatGPT is AI. Yeah, ChatGPT is AI. But so in order to expand this one a little bit, maybe I would like to have Ken Yong to explain to us. Mainly people talk about, because we have been doing some vision AI, all these things. Yeah, actually, how many type of AI, artificial intelligence we are having right now in the general application?
Okay. So when we're talking about the AI stands for the artificial intelligence. So there are two major branches currently. The first one is the machine learning AI. So, and then the second one is the deep learning AI. So the machine learning AI, I think, is the one that is everyone know already, especially those who are working in industry for many years ago. So when we talk about the AI, they will think about that one is the machine learning. And then depends on the application of the machine learning. Some of them, if they are dealing with the sensor data, then they might use the machine learning to perform some predictive maintenance or do some forecasting that are related to the numbers. Then for those who are in the industry that need to deal with the vision, the computer vision side, then they will use the machine learning to do the object classification, object detection. They want to detect the defect on their product. So the machine learning can apply in these two fields. So one is related to the sensor data, and another one is related to the image. Okay. Then we come back to the second technology, the deep learning one. So the deep learning also can do the same thing. And in fact, the performance of the deep learning is better than the machine learning a lot, especially in the vision side. But for the sensor data side, actually is moving forward now. So I think soon, one day, it will outperform the machine learning methods in very soon time. And then why we say the deep learning is better than the machine learning, especially in the computer vision side, is because the way the deep learning process the image. So it has the ability to automate, extract the important feature and learn those important features that can help AI to recognize what is this object, or what are the important things or important features inside the object. So while using the machine learning way, you need to do the handcrafted feature, which means you need to identify by yourself. You need to identify the feature. What are the important features by yourself? So you need to, maybe for this object, the shape is important, the color is important. And then when you go to if you want to detect the defect, usually defect come with different kind of shape and color. And this makes the machine learning engineer life very tough when they are trying to use the machine learning to solve the defect problem. But using the deep learning is different thing. You just need to show for previously, we show the image that contain the defect to the deep learning model. And then the deep learning model will extract the feature of those defect area. And then it will learn by itself. And then that one is, we are using we call it the supervised deep learning. And then
before that, I just want to 打岔一下. Okay, somebody asking me about why is it called deep learning? Actually, does it sound, because it sounds very, very funny. Why is it's deep learning?
Why is deep learning? Okay, so because deep learning is using the neural network, a very deep neural network, to do the learning. So the neural network is like a neuron in our brain. So our brain consists of many neurons. So when we apply this kind of concept into the AI, so that's why people call it a deep learning. So compared to machine learning, you tell the machine what are the things you need to learn. So that's why the machine is learning.
Is it because of the number of layers that, when we talk about neural network, it can, have a number of different layer that also contribute to this naming called deep learning?
Yes.
Is it one of them?
When the number of neurons is more than one layer, especially the hidden layer, we talk about the hidden layer. When the number of hidden layer is more than one, in the academic world, they say this one is already considered as a deep neural network. And it's a deep learning already.
Okay, one more question. We're talking about this deep learning. Let's say ChatGPT. People is doing the ChatGPT. Yesterday we had a I saw the experience. I saw this the Microsoft is trying to push the co-pilot. While you're running the Word, you can have a site there. You can ask something. That kind of open AI they included. So for this part, ChatGPT, is it part of the deep learning?
Yeah. Yes.
Oh, it's one of them. Okay.
Yeah, it's one of them. So the ChatGPT is considered as a deep language model. So it's different from vision. It's different from the sensor data. So it's another branch. So we're dealing with the language.
So you have something that you haven't finished just now. Because I do a time break because I stopped you just now.
Yeah, I think you should cover everything already.
Okay, so we talk about deep learning and machine learning. What are the difference? And then one of the areas, since you see Axiomtek, we have quite a number of wonderful edge. We call it edge AI. Edge AI. Before that we were pushing a lot of this industrial IoT edge. So what is basically this edge AI? Basically,
Okay, so edge AI is not something new already. So which means we run the AI inference, or we run the AI model on the edge device instead of you send those inference job to run in a server, now we separate let some small device to run the AI already. So we are not a centralized processing. We distribute it to the edge device to do the AI job.
So for a simple explanation, edge don't run on the cloud, So it's at the edge of the cloud. So we call it the edge. We call it the edge. So it's doing the some local processing before connecting to the cloud, before exchanging the data from, to the cloud servers and things like that. So this part, of course, in terms of edge, there is an IoT edge device also, So it performs almost the same thing. So today, let's come to the today. Actually, we are demonstrating. Kenan is going to demonstrate to you some of the edge devices. Especially this part, we can consider them as a IoT edge and also AI edge.
Yes.
So this part, that is to patch out the very first session that we have. We have this here. We have this vibration sensor again. We have a vibration sensors. This is a vibration sensors. So it has a magnet, that is attached to the blowing fan right now. We use the two blowing fan to simulate a different kind of vibration from the actual place. So this part, and then we are going to show you how AI is how does it come. So before that, I just want to hear from you. If you are watching, you can chat with us, or you can ask any question at all. If you have, you can also chat with us in this area. So maybe we can go on to show the other part.
Okay. So we have each device over here. So this one is our Kiwi Board. So I think.
We talk about Kiwi again.
We talk about Kiwi again. So this one is the Kiwi Board. So last session, we used the Kiwi Board to do some deep learning to recognize to do the analog meter reader.
The non-intrusive analog meter reading, performed by this Kiwi Board.
So last time we're using the deep learning technology. But for today, since we are dealing with the sensor data, we want to collect the vibration sensor data, and then we want to detect is there any abnormality occur. So we will run the machine learning algorithm inside this board. So this board not only can run the deep learning, it also can run the machine learning. Usually, if the board can support the deep learning, machine learning is not a problem anymore. Because the computing power required by the machine learning algorithm is less than the deep learning algorithm a lot.
Okay.
So over here, we have this one is the sensor, vibration sensor. We attach to the fan. So you're collecting the vibration data that consists of the sound, acceleration, displacement, velocity, frequency. There are a lot of data, and then it will send to this IoT gateway. So this one is a 4G IoT gateway. So the data is sending out through the 4G antenna. Okay. And then the data is sending to our cloud. But we didn't do any processing on our cloud yet. And then we use the Kiwi Board, connect to the internet to subscribe back to the data, collect the data back, and then we run the machine learning algorithm over here to process the data, see whether the incoming data contain abnormality or not. So, and then let's switch to the screen. Okay, so over here,
maybe big one.
I think it's a big one. Okay, so this is the interface connected to the Kiwi Board. Okay, so same like the previous things for the first session. So the first session, we are showing the interface from the cloud side, but this one is running locally. So you have the similar interface. So first, we can choose either you want to do the training, or you want to run the inference, or you want to stop the device not doing anything. So now I show you a very simple demo. So for example, now I want to start training the machine learning algorithm. So I just click training, and then the slave ID, you need to know the slave ID of this sensor device. So in this case, it's 1. And the protocol is we are using the RS485 to transmit the data from the sensor to the IoT gateway. And then over here, you can choose the machine learning algorithm. Yeah, we support different type of machine learning algorithm. And then we select the record data set duration. So how long you want to collect the data set for training. So in this case, I just choose a minimum 60 seconds. And then just click submit. So now the data is being collected by this Kiwi Board. And then after 60 seconds, it will start the learning process. And then after the learning process finished, it will automatically enter the inference mode, which means it run going to the deployment mode already. So it will give you the prediction in real time.
So we have to wait for a number of seconds.
Yeah.
So basically, right now we are doing some
data collection process.
Data collection process. After the data collection, that deep learning will start running, is it?
In this case, we're using machine learning only.
We were using machine learning. Yeah, ML, machine learning.
ML is enough already.
We use machine learning. We do some, that is for the abnormality, right?
Yes.
So we are doing some abnormality testing. You know why we want to have this part actually? Also, we have some followers who give us some comment. They say, this is a small matter, small thing also you want cloud to do, man. So that is a thing that we are not very happy. Okay, never mind. We don't want to use cloud to do. We use a Kiwi Board to do the machine learning for you. Yeah.
So we implement the HAI over here.
Yeah, okay.
Okay, so now it's already entered the inference mode. And then the abnormality detection is 0. Because now we are putting the vibration sensor on a good fan. So it will show the abnormality detection is 0. So let's say if we move the vibration sensor to another fan, it's bad.
So of course, we use these two fans to do simulation. One of them vibrate, as not as normal as the other one. So from
now it shows the anomaly detection is 1. 1 means abnormal because the vibration of this fan is different from another one.
Okay, that is a machine learning with Kiwi. Yeah, you want to realize the machine learning in Kiwi board. A tiny giant, I call it tiny giant, very tiny, but it can do the giant kind of the task. Yeah. So this is the way where this is all about this what you call the Kiwi Board. We have our crew here just show me this one. So actually we have this QR code. You scan us here. You are able to join us. Okay, not yet. sorry. We haven't come to that part yet. So where are we now? So we are still here. Okay, we will continue with this one. Okay. So basically, in terms of application, okay, since this tiny giant like Kiwi 310 is able to do this machine learning thing, so you can also use this one to use this same architecture with some configuration. You are able to do this machine learning on any of the abnormality. For example, if you are talking about light, the lighting, that kind of environment, you want to detect, is there any abnormality? You can do that. Vibration is one of the things is very practical, especially for pump, motor, leaf, all these things are very application that you need all these features. So machine learning can be applied in many areas now, of course. So you can imagine something that you want to do. We are able to do this part for you. So talking about Kiwi Board, we have what we call the if you want to get to know more on how Kiwi Board and then how this thing is being done, because I know in this life we are not able to show you everything. Yeah. So if you want to get to know more how this thing is being built, including the intrusive analog meter reading on the AI and machine learning, you can, I would like to share this QR code. You can scan this QR code. You can join us. Yeah, you can join us. We will share more information to you. Yeah. So in this QR code, you can see this QR code. You can scan, and then you can join us. We will share more information to you. Then once you keep in contact with us, we can arrange even a demo. If let's say you want to walk into our office to get to know how. Yeah. As you know, Axiomtek, we work very closely with system integrator, project house, system developer, machine maker. If you have this set of application that you want to do, no obligation, you come to us, we give you free advice. Yeah, so that is one of them. And on the other thing, if you can see some what you call the you can see the other QR code. Can we pull another QR code? As you know, we on the 27th, yeah, on the 27th, we are having another session on the webinar. Some of you already signed up, I believe. If you are following our this channel, you already sign up. That part is talking about autonomous mobile robot builder package. Yeah, on the 27th, 2:30 p.m. I'm not talking. My Taipei colleague is talking to you about how you can build AMR. This is come with the AMR controllers. There are a few pain point that you can tackle. We are tackling some pain point in the industry. For example, you are a AGV, you want to migrate to AMR. That's one thing. If you are talking about you want to get a better accuracy, you want to catch the timeline or time to market, we share with you how you can use this one. Or if you're already an AMR developer, you are running on ROS 1, but you want to migrate to ROS 2, and then you want to tap onto how to build some of the device more quickly, or even you need some hardware to allow you to do, for example, for autonomous mobile robot, there is one part that you want to build. For example, you want to build a forklift. Yeah, you want to transfer things from up and down, but you need cameras. This our hardware is able to support GMSL camera that you can, do a high speed on a long distance to do certain things like that. Yeah. On that day, Mr. Sinrik is going to share this part. It's a 1 hour webinar. If you are interested, you can register here, and then we will see you there. Yeah, that is another thing. Yeah, coming to the end of this live session, just for your information, you are watching the Jom Let's Sembang AIoT again. Me and Ken Leong here presenting to you. And if you like this channel, please follow us. Sometimes we just call for, sometimes Ken Leong has got some new idea we want to share with you. He will do the live straight away, or myself also. So you can like and subscribe, and put an alert so that you can see us in the next session. Yeah. So for this, me and Ken Leong, I'm signing off from this live channel again. I hope we can see you in the next session. Okay. See you. Thank you.